We'll start with a common security term, HTTPS. With the S standing for secure, people often better associate this with their browser displaying a padlock symbol next to the URL. HTTPS is the secure version of HTTP, which is the foundational protocol used to send data between clients and servers. However, HTTP transmits data in plain text, whilst HTTPS encrypts data using SSL or TLS, preventing others on the network from accessing the information being sent. Nowadays, all respectable websites and APIs serve HTTPS, and so we should do the same for ours, especially if we are handling sensitive data or require authenticating users, as otherwise users simply won't trust us. Also, if an employee logged into our HTTP site using a public Wi-Fi network, attackers would simply be able to read their credentials, meaning they could later act as if they were the employee and perform bad actions. The most secure configuration is to simply redirect all incoming HTTP traffic to HTTPS. Plumber does not support HTTPS natively, but in the hosting section we'll provide a few options for how to do so. Next, we have firewalls, which are network security devices that monitor and potentially block incoming or outgoing network traffic based on a set of rules. They are important since they can prevent unauthorized access and help protect against attacks. A classic example is only enabling access from certain IP addresses, which belong to either particular trusted people or a company-wide VPN. Firewalls can also restrict access to certain ports on the server. So for example, a user logging into a machine remotely using the SSH protocol might only be allowed access via port 22. Otherwise, they'll be instantly blocked. Many servers and hosting providers offer the ability to implement firewalls. Although we can mimic some firewall functionality in R, as we'll later see in this section, implementing them at the network level instead is optimal, since this doesn't impact server load and can block a full range of services. A denial of service attack, or a distributed denial of service attack, also known as DDoS, is a malicious attempt to disrupt a system or service by overwhelming it with a flood of requests or traffic. Firewalls and limiting the number of requests a particular client can make within a certain time frame, called rate limiting, are some methods to mitigate against these attacks. Large websites are often targeted by attackers with different motives, and it is not uncommon for some sites to suffer downtime because of this. From a plumber perspective, it is important to consider the resources that are utilized by each function, like endpoints. Endpoints which take a significant amount of time or undertake expensive computations are the prime cases to be attentive to and to protect. If attackers send simultaneous requests to these endpoints, it could cause the server to run out of memory or consume all the CPU, resulting in other API resources being deprived, and potentially cause Plumber to crash. Thankfully, our current API implementation does not involve too much computation, although one potential red flag is the flight search endpoint, which takes an array of dates as input. Our code converts the entire array to dates from strings, and then checks the array for any NA elements. This looks harmless, but if an attacker issued multiple requests with an array consisting of thousands of dates, memory and CPU on the server would increase as it tries to perform our validation. One solution here is to return an error if the array is over a certain length, or to simply trim it to a defined maximum length. Let's implement a 400 error when the array has more than 100 elements. We'll say if length dates greater than 100, we'll respond with the 400 error. and we'll return the message. Parameter dates has too many values. Indeed, any logic based on user input should be inspected to ensure there are reasonable safety guards in place. Let's check out our pricing endpoint calculation. The current model is not complicated, but if the data science team propose a new model, which can take many seconds to provide a price, this becomes an endpoint that requires protection. Rate limiting is a good contender for this type of problem, or captures and bot detection methods could be used on the site once a certain number of requests has been reached. In our server routing files, we can configure requests to only be accepted if they are coming from our website directly, as opposed to a curl request. And we could also implement caching, which stores the result from some input and then reads the result for future requests with the same inputs. We should configure caching carefully though, especially for entities that are ever changing, such as flight prices. As a final point of mitigating against denial of service attacks, it is recommended to use a content delivery network, or CDN. These are networks of distributed servers that cache content closer to the end user, reducing latency to view web pages, for example. But most importantly, they can absorb extremely large amounts of traffic. They also offer other benefits, such as hiding the address of the origin server, and the most popular ones provide bot management, real-time alerting, and SSL or TLS encryption. In the hosting section of this course, we'll utilize Cloudflare as our CDN, as it can also manage domains. Similar to the previous topic of implementing safety guards on user input, there are other consequences to consider, as well as denial of service attacks. Users could utilize the input fields to cause malicious actions or to read sensitive data. For example, if we have an endpoint which takes a file name as a parameter and returns the data in the file, this logic could be abused to instead print the contents of files unintended to be accessed, such as server configurations or even API keys. Hence, all user input should be properly sanitized. Cross-site scripting attacks, or XSS attacks, allow the injection of malicious scripts into web pages, usually JavaScript scripts, which execute on the victim's browser and can steal sensitive information or download harmful software. Whenever user input is rendered in a browser, this type of attack should be a concern, and all HTML entities should be escaped, which means treated as plain text rather than executable code. A classic example of this is in a comment or review section of a website, so always bear this in mind. Cross-site scripting attacks are one type of injection attack, the most common of which are SQL injection attacks. These occur whenever user input is improperly included in SQL queries. For example, if user input is blindly passed into SQL queries, the user has the ability to add their own where clauses in order to view the entire table, or they could also add drop table statements. To combat this, parameterized queries should be used, rather than directly concatenating inputs into a string. The RDBI package supports this and automatically escapes and quotes user inputs. Lastly, web browsers implement a security feature called Cross-Origin Resource Sharing, or CORS for short, CORS, which controls the web page's accessing of resources from a server on a different domain. By default, browsers enforce the same origin policy, restricting JavaScript from accessing the server's response if the web domains are different. In these cases, the browser will initiate an options request, a method type we briefly mentioned at the start of the course. The purpose of the options method is to request information about the resource before making the actual request. The browser can inspect the headers in the response from the options request which may specify that the cross-domain requests are indeed allowed. We'll cover how to set these headers and allow cross-domain requests in the next section. That's it for the basic security overview. Next up is another important Plumber concept called filters. Stay tuned in